Okay. Okay, guys, let's start. Okay. Some quick announcement here. Okay, quick announcement. Lab 1 Part 2 has been released. You better start soon. And it requires the knowledge about 2D arrays and nested loops. If you don't feel comfortable, I think it's worth spending some time at this point. To give you proper credits that you spend any time on this lab, I'm going to include these topics in the lab test 1 that you're going to have. So your time will be worthwhile. Okay? Nested loops, and also two-dimensional array. Okay, about today. We're going to talk about exceptions. So exception is doing something that you haven't seen from 1022. Especially we are talking about when error happens, the flow of control can be interrupted. So that's something definitely new to you. So today I'm going to give you a series of examples for us to get a feel about how exceptions should work. And that's the best way to learn. If you really got confused at any point, please let me know. It's quite a confusing topic so far. Okay, let's just have a very quick review on why we need exceptions, very quickly. Okay, and then let me first of all switch to my code fragment here. Let's just see why, in the simple case, why we need exceptions, very quickly. Okay, let's review what we had last time. We have a class called circle, and we have an attribute called radius, and then for the mutated method, set radius over here, when the R is invalid, being negative, what we do is we simply just print out some error message to the console. That's what we do. And we say that this is not good enough, simply because let's think about when the caller is trying to use this fragment of code. Let's see what's going to happen. So now we want to see the caller, which is circle calculator class over here. You can see inside the main method over here, we are trying to make this method call over here. We say whatever circle we created, c.set radius minus 10. Okay, from this context over here, when you are calling a method, you are supposed to give valid values in order to do the calculation. But over here, the caller, the main method over here is passing minus 10, which is invalid. What's really unacceptable about the solution over here is, after this line over here, we can still go to the next line. So the flow of control is not interrupted. So that's unacceptable. We want to say as soon as you pass some invalid input over there, the method itself should really tell you there's something wrong. You must handle that right away. Okay? So you shouldn't be able to continue to the next line. Okay? So that's really the point we were trying to emphasize last time in the simple example. This line should not be continued to be executed. Okay, that's the main point that we said last time. If you use exceptions instead, that means in this line over here, let me just give you a little bit of preview. Set radius over here is I'm going to show you exactly how you can throw exception when error occurs. As soon as you're trying to pass an illegal input for the set radius method, it is going to throw some kind of exception. After which, there's no way for the caller at the main method to continue with the execution. They must do something right away. They cannot simply continue. Okay, that's kind of the idea. Okay, that's about the review from last time. Let's have a look at a slightly more complicated example. We already went through the code, but let me just review very quickly so we are on the same page. Okay, we got 3 classes over here. As you can see, I have a table over here, which eventually I would like you to fill up. Conceptually. It's really important to know the caller and callee. Remember I said before, the same method might be the caller and callee at the same time, depending on how we call them. Okay? Let's see very quickly. Again, we got 3 classes over here. We'll go over one by one. It's crucial to understand the caller, callee. And then I will also explain the concept called stack at the end. We'll get there. Okay? But just have in mind. Okay, let's see. First of all, we have a class called account over here. And then the account class has a method called withdraw. For the withdraw method there, we say that we're going to print out the error if either the amount is negative or if the amount subtracted from the balance will be negative, which means the amount is too large, right? So either this or that. So we got two possible sources of error condition, okay? Again, we are not using exception. That's why I want to show you again why it is unacceptable, okay? We just print out error. That's the first class, okay? You just pay attention to withdrawal. You don't have to worry about deposit. Okay, the second class, let me use a different color here. What about blue? So we have second class called bank, and then we have a mutated method there called withdraw from. And over here, we're giving one extra input because in the context of a bank, we have more than one account stored. That's why if you want to locate a particular account, you want to know the ID. Okay, that's why you got an ID over here. And then we simply run the loop, and then we say that for this particular account that matches the ID we're looking for, we're going to call accounts I.withdraw A. Okay, you can see that over here, the withdraw method over here, the context object is this. What's the type of accounts at position I? What's the type? How can you tell? So what's accounts? Accounts, as you can see over here, was declared to be an array of account, which means every element in the array accounts is going to be the address of some account objects. So if you go to a particular index, it's going to be telling you where the account is. Okay? So now, this withdraw over here, it shouldn't be too surprising that this withdraw is exactly this withdraw over here that we are talking about previously, right? We're calling that particular method. Okay? So in the bank, we are trying to invoke the method from the account class. Okay? Two classes so far. Any questions so far? Two classes. Okay? Let's go to the third one. Okay? The third one is going to add more complication, but in a similar fashion. So let's see over here, I'm going to use pink. So let's say we have the third class called bank application over here. And then over here, we have the main method. Okay? So now the main method is the caller. Okay? And then over there, you can see over there, we simply create a bank objects over there. And then we say b.withdraw from 23 and then certain amounts. And the amount over here is simply, we just read it from the user. So the user can enter -20, or they can enter maybe 40, doesn't matter. Okay, just something from the user. And we learned about how to use scanner previously. If you got trouble, let me know. Okay, that's about the third class. And now you can see that again. Let's have a look at this method call here. This method call here, you can see the context object is B. And B is of type bank. That means we are calling some method from the bank class. But which one is it? You can see it's the withdraw from method over here, which is here. We're calling that method there. Okay, and then we are passing whatever user input to be the amount to withdraw, and then whatever ID we're searching for, something like that. Okay? So now we definitely have several method calls over here, and they're kind of related. Okay? Okay, that's the three classes we're talking about. And then before we sort out how the error handling is going to work at the moment without the exceptions, let's just fill in the table together. So that will also help us understand the complexity of the chain of the calls and also introduce some terminology. Okay. So now, I would suggest when you try to execute this particular project over here, which one would you execute? Whatever class that has the main method, right? So you will simply just do the following. You will right-click on this class over here, and then you will say run as Java application, right? That's what you would do in Eclipse. Okay, so let's start from there. So now in the bank application, I will help you with the bottom row over here. So we start with the bank application here, and then the caller is the main method. Okay? And what about the callee? Who's being called? Well, bank, but you're saying bank is a class, right? Which method? I'm talking about this line specifically. So we're talking about the bank class, and then withdraw from. Sorry, let me write it a little bit better. Withdraw from. Okay? So now, when we call withdraw from over here, let me just try to draw some arrow over here to show you the dependency. So when we try to call this method over here, that means we're going to refer to this context over here. right? That's kind of the direction of calling. Okay, so now we are now in the bank class. That's the context. Okay, now who's the caller? Which method? Bank apparently is a class, right? But who's the caller method? Withdraw from. All right, very good. So I would say bank over here, and then withdraw from. Okay, who's the callee? You can look at this line here. Who's the callee? Who's being called? Well, apparently it's a withdraw method, right? From which class? Account, yes. Thank you. Let's put it down. And then I will put account over here. Sorry. Account and then withdraw. Okay, as soon as we try to execute this call over here, that means for this particular line, it is going to bring us to another context of the class to here. Okay, the withdraw method. Okay? And now finally, we are reaching the account class, and apparently the caller will be account class, and then withdraw. Okay, that's about it. Okay, there's no further method call. That's why there's no further callee. Okay, so now this filling up the table here is one way to present a picture. But let's simplify that a little bit. How do I simplify that? Apparently, you can see that over here, the callee over here is the same as the caller over here. Agree? Similarly, the callee over here is the same as the caller over here. We can simplify that by collapsing the duplicated one into one single. Okay? What do I mean? Let me draw it over here. So that means we can have something like this. And there's a reason I draw it like this way. I'll show it to you in just a moment. So we start with bank application class and the main method. That's where we start from. From there, we try to initiate a call withdraw from the bank class. And the bank class, we have the withdraw from. And then from there, we also call the withdraw method from the account class. So we got account and withdraw. The same, but I would say this latter way is a little bit easier to understand. And there is a name for this. It's called stack. We wouldn't really cover the stack. It's a particular data structure. We wouldn't really cover that in this particular course. We used to, but we decided we're going to leave that discussion to 2011 later. But let me just tell you the most important feature you have to know just for the purpose of this course. So when we talk about a stack, the property you should know about is something called LIFO, okay, standing for last in, first out. Okay, last in, first out. What does that mean? That means when we first call this particular method here, the main method, right? Before the main method can terminate, we have to make sure we call this method here, withdraw from. And before this method can terminate, we also have to call this method here, right? Withdraw. And now you can see that over here, for the withdraw method, we either go to if or we go to else, okay? This is how the Java execution goes at the runtime. Either we go to if or we go to else. If we go to if, let's say we print out whatever the error message it is to the console, and then we terminate the withdraw method. Then what will be the next step for the Java runtime system? What they will do is they will say, so this is called a top. Guys, remember the class protocol? Please, thank you. Okay, so this is called the top of the stack, and this is called the bottom of the stack. Okay? So basically, the Java runtime system is going to say, well, whenever the top of the stack of the method has terminated, we're going to get rid of it. And then we go back to the new top, and then try to execute it from the remaining lines. And then after that, we're going to get rid of it, and then eventually we'll finish the main method. That's kind of the details for how you execute a code. Okay? But as far as we are concerned, all I want you to understand is about the caller and callee relationship. So bank application domain calls bank withdraw from, which in turn calls account withdraw. So these are the three elements of the call chain. Okay? Any question about this chain over here? Okay? It's kind of a sophisticated, but even for simple example, you can see how things are done for you automatically at the runtime. But it's really important to know this. Question? Yes.
So the account can be a callee, but it's not a callee.
The account class,
No one's calling.
Oh, just at the moment, yes. You can see that. Let me just emphasize that. The question was why this cell over here is empty. Why? The reason is because if you look at the withdrawal method over here, okay, you can look at that. You can see that we simply have no further method call. We either print out the message or we simply just decrement the attributes, right? We didn't do anything else. If you try to make another method call, of course, the call chain can grow.
So my question was actually,
Uh-huh.
the stack, how can you tell
Uh-huh.
if there was a callee or if there wasn't a callee for that account? Because there's nothing on top of it?
Oh, yeah, exactly. Because at the moment, yeah. So the question was, if the stack looks like this, and it doesn't really grow any further, that simply means this particular withdrawal method here makes no further method call. That's why it doesn't grow, yes. If it doesn't really make any further method call, that means we are closer to the termination of the method. Yeah, so these are just a little bit more lower level details. Okay, but as far as learning exception is concerned, you should really know the chain of calls that's happening. Okay, because later on when we talk about handling exception, you have to follow through this kind of chain of calls and see how you can handle the exceptions. Okay. Any question about this example here before I move on? Okay. Okay, apparently you can see this one here. It's not so complicated, but the call chain that you will need to spend some time understanding how it can be inferred. Okay. And realistically, you might have a call chain maybe of 10 different method calls. It's definitely possible. It really depends on application. Okay, good. Let's now talk about exceptions over here. Let me see if that's the next topic. Yes. Okay. So having these two examples in mind, we know that simply put console error messages are not the way to go. We want to have a way to really force the caller, if they pass any invalid inputs, to stop right away. We want to have a way to do that. Okay? How do we do that? So the way to do it in Java is by exceptions. Okay? I want to show you something like a source code over here. If you download the source code there, okay, let me show you the first one here. Basically, if you download it, let's say for the circle example. So now let's have a quick look at the circle with exceptions. How about let me go through the code with you very quickly, so that'll be easier. And then I'll go to Eclipse and show it to you. Okay? Okay, that's the code over here. So let me highlight the difference. Okay, so now we are talking about the better version with exceptions. But what's really the difference? Let me highlight it for you. Okay? So we still have a circle class. We have a radius attributes. But now this is something that's new. It says throws invalid radius exception. And also, under the if over here, we used to say system.out.println error message, right? But now we simply say throw new invalid radius exception and then give some error message. So these are the two pieces of new stuff you have to implement by yourself. Well, by the way, remember what this is called? Which we talked about last time. Anonymous object, exactly. You can see apparently over here, I simply say, of course I'm going to explain what throw really means. But after the throw, we simply say new invalid radius exception, right? What we could have written, which you definitely can try, it's nothing wrong with that. Let me just show that very quickly. For this line over here, you can definitely say, I can say invalid radius exception. And then I'll say E. It's assigned to new invalid radius exception. And then whatever error message over here it is. And then I can say throw E. So these two parts are completely equivalent. If you still don't feel very comfortable about the left-hand side, then feel free to write the right-hand side. Nothing wrong with that. Okay? That's the first part to highlight. Okay, so there are two parts you have to know. Okay? And it's really very confusing over here. First of all, notice that these two words are different. One is called throws, the other one is called throw. Different, okay? Don't put it in the wrong place, your code wouldn't compile. Let's talk about the throw under the if branch first, okay? That one there is simply say, throw is more like a verb. You want to do something right away. Okay? So that means if the radius r is less than 0, what I want to do is I want to throw an exception at this point right away. So the exception will be known to the runtime system. And the caller of this particular set radius method will be somehow interrupted. That's what it means, throw. Just do it. Okay? Throw. And every time when you say the throw over here, it is expecting over here some exception objects. Okay, and you might be wondering where this comes from. I'll show you how you can do it in Eclipse. I'll show it to you. Okay, David.
Why use those that have like arbitrary places?
Good question. Usually, it's a very good question. So the question was, over here, why do we say throw as opposed to return? Very good question. Let me highlight that. There's a conceptual difference between throw and return. From before, when we are trying to implement accessor, and we say return. Let's say get BMI. Whenever you say return, that means you're returning the value and everything up to now has been okay. It's a normal return, normal execution, normal. Okay? On the other hand, let's say also either in any of the method over here, it doesn't have to be accessor or it doesn't have to be mutated, it doesn't have to be. Okay? Whenever you say throw, you're indicating to the runtime that something has gone wrong. I want to interrupt my caller right away. Okay? Throw, which means abnormal. Okay? Make sense? Okay. Any questions about this? So don't get confused to say return new invalid radius exception. No, that's not the way to go. When you say throw, you don't say return. You say throw.
So like as a way of error messaging.
Exactly. Yeah. You basically, rather than say system out of print line, you say throw new some exception objects. Right? So the throw is going to interrupt rather than just returning something back to some caller. It's different. Okay? Okay. Now, let's see, that's about the throw keyword, and also over here, throws over here. You can see that, let me show you one thing here. So where does the implementation of this set radius go? Implementation. You can see the implementation here. It starts from, let me use different color here. It starts from this curly brackets here. It ends with this curly brackets here. You can see the throws invalid radius exception goes before that. Right? So now remember we talked about header and signature before when we did the review. So whenever you say throws invalid radius exception here, that means as part of the API of the method or as part of its signature, we are telling any potential caller who might want to use this method that when you call this method, you gotta be careful. You might trigger some invalid radius exception. So that one is more like a public information to be known to any caller. Okay, let me write it down. Okay. Again, you have to know the difference between throws and throw. They're different. So this guy here, so this information becomes part of the API to inform the potential caller of set radius. Okay? And we'll see, when we say inform, it will be a little bit stronger than that, not just to inform, but the caller of this particular method, which might throw the exception, the caller must do something. Must do something. Okay, and below the code fragment for circle calculator 1, it shows you one example, what they can do. Okay, I'll show it to you. Okay, so now let's see the fragment down. So now we talk about a caller for the radius class over there. So let me use maybe green. So we got circle calculator 1. I do have circle calculator 2 for you to think about. Let's go with the easy one. Okay, so over here we have a new object of type circle. So now this is also something new for you. Okay, basically, let me just also highlight because that's also new. Try and catch. Okay? Let me just preview a little bit. Whenever I'm trying to call a method which might throw a certain exception, I have two options over here. I have to take either actions, not both, either one. Number one, I can do whatever, I can do exactly like what's shown in iPad over here. I can do try this particular method call and catch if the exception is actually thrown. That's option number one. And number two, I can choose to ignore this particular exception. I can choose. I just don't want to handle that at this point. I want my caller to handle that. Remember we talked about the call chain, right? We talk about withdraw from, and the main method, right? If the withdraw gives me this particular exception, withdraw from has two options. They can either to do a try and catch, handle that right away, or they can say, propagate that into the main method. And when we get to the main method there, they have to, they got a similar two options. They can either try and catch it, or they can propagate that to where for the main method, to the console. Okay, that's something I will show you as illustration. Okay, so let's just go through the syntax very quickly. So when you do try, it has to be a block. Also, when you do catch, you have to specify which kind of exception you want to catch. Okay, so let's just make it simple. Okay, depending on how many kinds of errors the method you're calling can trigger, you will put this many catch. At the moment, because we know, let me show you. At the moment, we know that set radius can only throw invalid radius exception. That is why you only list invalid radius exception over here. Let's just match the name, just easier for you. But later on, let me preview again a little bit. Towards the end of the course, we're going to talk about an advanced topic called inheritance. When inheritance comes into the place, the catch block can be a little bit trickier, but let's not worry. I just want to let you know. Okay, let's understand the basics first. Okay, let's go back there and finish the code over here. So basically we say over here, c.set radius over here minus 10. Okay? In the version without the exceptions, what's going to happen? Basically, this method over here is going to print out some error message there, but we will still continue to the next line, and then the next line. That's what we would do, right? But now, since we got exceptions, things will go a little bit differently. Okay, let's see exactly what's going to happen. And then I'll show you on the Eclipse. Okay, over here. So now let's say, okay, actually let's go directly from here. So now this, when we try to execute this line over here, c.set radius minus 10. Okay, so set radius with r being minus 10 is going to go into the if branch. And the if branch is going to throw this particular exception object, as we know. Okay, so now let's highlight that. So that means this line here is going to throw new illegal invalid radius exception. That's what you will do. So the consequence of doing this is completely different from if you put an error message simply. The consequence is the flow of execution for this caller here is interrupted, which means you will never get a chance to go to the next line. No. Never get a chance. That means the flow of execution after this line here is going to go to the catch block that matches that exception there. Because we know that illegal radius exception, invalid radius exception, matches this exception over here. That means we'll go into this line over here. That's what you would do. Any question first? And then we'll go to a little bit more advanced example to strengthen your understanding. Yes?
When we're learning the anonymous object,
Yeah.
you said when we make an anonymous object,
Mhm.
we never called it.
Correct.
Now here we're calling it and we're having a name.
It's different. So you can think about, it's a very good question. The question was, as far as this block is concerned, when we say throw new invalid radius exception, this object here is anonymous, right? So basically, it's like we return this particular object to the runtime system. And then the runtime system is going to pass this object to this catch block. And when they pass this exception to the, when the runtime system passes this object to the catch block, they are going to give a name at this point, right? So this kind of management is done automatically for you, so it's different. It's anonymous only in this context over here. But when you actually throw it out, when you catch that, it has a name as declared by E over here. That's why we say E here.
So if parents using the anonymous when you put the right side of the loop.
Yes, it's
You needed a Trojan at that point, right?
yes, correct. So if you actually chose to use this version instead, you may do something maybe in between by using E. But after you say throw, you cannot do anything else. Yeah, throw is like the end of the story because you throw the error. Okay, that's good. Okay, okay, guys. Any question about this particular simple example? Yes, go ahead.
So if we remove the try and catch system and just go with set radio, so it will still give out the error, but will not terminate.
Good question. What if we simply remove the try and catch block? The simple answer is it wouldn't compile. It just wouldn't compile.
Okay.
The reason is, I will show you right away. It's a very valid question. How about we do it right away? Okay. Okay, you should really try this as well. So now let's go to under the package circles with exception. Okay, you can see that for circle, oh, actually, we're talking about circle, right? Good, okay. Okay, we got circle over here. And then we have circle over here. You can see the circle, as we said before, the set radius method throws invalid radius exception, right? So now let's go to circle calculator over here. You can see at the moment everything compiles because we say try and catch, right? So now let's see how we can play with what you just suggested. Let's say we forgot. I'm simply just going to comment out everything about try and catch. Okay, you can see that over here we simply got c.setRadius and then do whatever we did before. And apparently there's a red underline over there, right? Let's read it together. Okay? Let's see what it says. It tells, I'll read it to you. Unhandled exception, type invalid radius exception. Basically, it's telling you that the caller, who is the main method for this class over here, the caller is trying to call a method called setRadius, but setRadius can throw this invalid radius exception. However, the caller is not trying to do anything with it. Remember I said they got two options, right? Two options. Either they can do try and catch, which means they want to handle that right away, try and catch. Or what about the second option? I'll show you the second option right away. Ignore. However, when I say ignore, it's not just like ignore, because what we're doing here is like ignore, but apparently it doesn't compile. If you want to say, let me say propagate, a little bit formal, which means I don't want to take this responsibility of handling this exception. I want to pass that to someone else, someone higher. What I can do over here is, I can say, pretty much like what I did for the circle set radius. I can say over here, this is something you haven't done so far. I can say throws illegal invalid radius exception. Everything compiles. That's option number 2, which means for me as a caller, even though I'm calling someone who might give me an exception, but I don't want to use try and catch. I want to take option number 2. It's easier for me. I simply declare as part of my signature, I might also throw this kind of exception and let my caller, if there's any, to handle this. But now let's think about, let me just, before I take questions, let's see what's going to happen in this case, option number 2. If now I try to say set radius minus 10 over there, okay, let's just look at the code over here. Okay, let me just maximize it for you. So now if we say set radius r over here, I'm going to give minus 10. In that case, that means it is going to call c.setRadius minus 10. And we know that that's going to trigger invalid radius exception. But at the moment, there's no catch block as before. So that means the exception will be propagated to another caller. But main method is really the entry point of execution. No further caller. The only thing can propagate it into is console. That's something very bad. Okay, let's illustrate that. Okay, so now let's go back to our package explorer here. Let's just do that right away to show you. So I can right click on this, and then I can say run as Java application. Enter radius, I would say minus 10. You can see that the exception is thrown directly to the console. For me as a user, I don't want to see anything like this. I want to see whoever my colleague is, they properly handle their internal workings. I don't want them just to propagate their responsibility to me. Okay? So the two options over here by examples. Any question about this? It's actually a very good question here because I kind of show you there are two options here for every level of the call chain.
What if like in one try and catch we call multiple exceptions?
Good question. So what if, let's say you try to call a particular method there, and that method might throw multiple exceptions. That means you get multiple catch block. Okay? Let's, you know what, we'll get there a little bit later. How about that? But just take my word for that. We can use or, yeah. Yes. How about I go into that a little bit too complicated for today. Okay. Okay, guys, if you have no question, let's try to strengthen our understanding a little bit. I'll give you a little bit exercise over here. Think about it and we'll do it together. I want you to look at, basically, I want to build on top of this code over here. You can see at the moment, if I say set radius minus 10, what would it do? If I say set radius minus 10 over here, what you would do is you'll simply match the catch block and then simply just print out the exception. Just do something. I want to do something a little bit more sophisticated. Okay? Let me illustrate to you. Okay? In Eclipse. Actually, I don't seem to have this code here. So what I would, let me just show you what I want you to show you over here. Imagine that this is the console, okay? Just imagine if this is the console. If I say enter radius, okay? And if I say minus 10, what your program should respond back to me is something like this. You would say invalid radius, try again. Okay, so the program hasn't terminated yet, hasn't. And then if I try minus 2, right, it would say, again, invalid radius, try again. And then until the point that I say, for example, 10, this is valid. In that case, it would say, it would be 314 for the area, right? Basically, what the program will do, it will repeatedly ask you for the radius if you have only entered negative values so far, until the point that you enter, you give me a valid one. Okay? That's kind of the exercise I would like you to think about just for 30 seconds. Definitely, you need a while loop. Okay? Let me just present to you the exercise over here, and then we'll go over the solutions together. I think that will strengthen your understanding. Okay, that's solution, but let's look at the exercise, okay? Over here, so we want to extend your circle calculator 1. I'll bring you to that page. We want to repetitively prompt for a new radius value until a valid one is entered. Okay, so here you can assume that the set radius method from the circle class will throw the invalid radius exception if it is negative. So somehow your code has to combine try and catch and some while loop. Maybe with some Boolean variable to tell you when to exit from the loop. Okay? Why don't you think for just 30 seconds before I show you the code? That'll be a little bit better. Okay? But meanwhile, I'm going to switch the code back to here so you can refer to it. It's only about 2 or 3 lines of extension to the code. Okay, just about 30 seconds, and then we'll do it together. I'll also make the source code available to you so you can play with them. Okay? Just in a class, it might be easier just to annotate the code to help you understand. Okay, give you another 10 seconds, and then we'll go over my solution together. It's only my solution, so if you got any other way to solve it, you can feel free to share. Okay, I'll go over them with you, okay, one by one, okay. So now, what I want you to look at is like this. First of all, you can see the circle class stays unchanged. Again, the set radius throws invalid radius exception. which means whenever you try to call this particular method, you got two options, either to do try and catch, or you can put throws invalid exception also in that particular caller. Okay? So now let's go over that. Okay? So this new class over here is circle calculator 2, okay? Which is very similar to number 1 over here, very similar. Let's highlight what I added. Okay? First of all, I added a Boolean variable over here. I simply call the input radius is valid. I assume in the beginning that the user enters something invalid to me. That's why I gotta go into the loop and keep asking them. As soon as they give me a valid value, I'm going to set this value to be true. Okay? So that is why you see the while loop over here. Notice that I have a negation over here. So not the case, it is not valid, which means, sorry, let me say it again. Not the case, it is valid, which means it's invalid. As long as the input so far is invalid, I'm gonna stay in the loop. I'll trace it with one particular input with you in just a moment, okay? And then, let's see another point of change over here. So over here, notice one thing here. This line here, I will set the input radius is valid from false to true. Notice where I change it. I change it immediately after executing this line. Let me test your knowledge from what I just said to you. If I'm able to go from this line to this line, what does that mean? There was no exception, which means the caller over here was not interrupted. That's a very strong implication over here. Bear that in mind. Okay? If I could go from c.setRadius r, execute it, and I can still go to input radius is valid, is assigned to true, that means there was no exception thrown. Otherwise, if I couldn't reach that line, what does that mean? That means exception was thrown and it went to the catch block. If it went to the catch block, like over here, in that case, the Boolean variable should remain to be false. That's why you don't see anything assign that to false. Just remain to be false. Okay, let's trace the program. Okay, so the orange part are simply the ones that you should really know to see that's the extension. Okay, I'll just highlight them. So these are the additions, just a few lines. But the logic over here is really important for you to understand exceptions. Let's trace two cases. Okay, let's trace maybe the valid case first. I'll use different color for that. So let's say valid case. Case 1. User enters 10. 10 is a non-negative value. Okay? So that means over here, this line over here, the user is going to enter 10. Just 10. Okay? And we enter the try block, and then over here, R is going to be set to 10. Right? And R over here is going to be set to 10. So that means we go to the else branch, right? 10 less than 0 is false. So that means we will simply set the radius to be R. That's what you will do. Okay, after that, we know that c.radius will be set to 10, right? So that means we can simply go to this next line over here. There was no interruption. And then we set the input radius is valid to be true. Okay, and then we execute these two lines as well. Do we go to the catch anymore? We don't. We either go to catch or we don't. Okay, so in this case, catch is completely ignored. Okay, and notice that this is the end of the while loop. Since we just set it to true, and when we go back to the beginning of the while loop, we're going to check this condition here. We say not the case, input radius is valid, but that Boolean variable has been set to true, right? So now not true will be false. That means this condition over here will simply just be false. So we exit from the loop. So we are done. So as far as the external user's behavior is concerned, since we enter a positive value right away, so that means we don't have to prompt the user for any valid input. It's already valid. Okay, follow so far? That's case number 1. Okay, you should really maybe watch a recording again to see how the two cases can be traced. Second case. Case 2. user enters -5, for example. It's a completely different case. Let's see what's going to happen. So that means we still execute this line over here, and then the user enters -5. Okay? And because it enters -5, when we say c.setRadius is going to be -5 for case number 2. So that means it will be -5 over here. And in this case, we go to the if branch instead, right? Because -5 less than 0 will be true. So that means we'll throw new invalid radius exception. So now that means the caller will be interrupted. Okay? So now what does that mean? That means after executing this line over here, we will get invalid radius exception thrown. Do we get to the next line? No. Where do we go to? Catch block. We'll go here. That's where we'll go to. Okay, we go to the catch block, and then we'll simply say radius -5 is invalid, try again. And now after the catch block, we reach the end of the if, and then we go back to the beginning of the while loop. And then this time, what's the value for input radius is invalid? Sorry, input radius is valid. What's the, is it false or true? False, because we didn't reassign that to true, right? Right? We only reassign that to true if we have got a valid value. Good. So now you can see not false would be true. That means we stay in the loop and prompt the user again. Okay, this program here, it's only a few lines of extension, but I would say it says quite a lot about while loop, about setting the Boolean variable, and also the try and catch block. I would say trace these two cases very carefully. So that will help you understand the meaning for try and catch. Again, the primary reason for using exception is whenever this caller is calling a method that might throw an exception, you want to do something about it. Okay? Any questions up to now? Yes.
In the catch block,
Yes.
invalid radius exception, after that it says E, so that's object of invalid.
Yeah. Okay, just very, sure, no problem. So over here, the question was, how do we understand this catch block over here? Okay, let me just repeat that over here. So you say catch, and then invalid radius exception, and E. This is saying the following. As soon as this particular exception is thrown from this callee over here, right, the setRadius method, it's going to be thrown to the runtime system. And then the runtime system will find that you have this particular catch, which matches this particular exception type. And then it's going to give this particular object, which used to be anonymous, used to be, in this context over here, it's going to give you the name, E. And then that's why in the scope of this particular catch block, you can definitely refer to E for whatever purpose you like. Yeah. But I would say typically, you will see that lots of the code, for the E, you'll simply do system, I don't quite remember. You can see one of the slides, print the information for this exception. I forgot the call name, anyway. Okay, any question about this before I move on? Okay? If you understand so far, it's not too bad. I would say we pretty much cover the essence about exceptions. Okay? But I'm going to give you one more example before end of today, just to make sure you're okay, comfortable. Okay. Okay, good. Okay, let's see the next one. Okay, that's basically exactly what I just said. Again, over here, basically you can see that the last two lines in the slides, I simply show you the two different cases, right? So you can also see which lines exactly will be executed, right? So I just did it on iPad instead. Okay, let's now talk about how you can create exceptions, okay, in Java, in Eclipse. Okay, let's see that very quickly. You can think about every time if you see a particular type of exception, it corresponds to a class in Java, okay? Let's go to Eclipse over here. There are two ways for you to create an exception by yourself, either manually or semi-automatically by Eclipse. I'll show you manually first, okay? Manually, very easy. Typically, let's say over here, let's say for setRadius over here, We say set radius, and then you say it throws invalid radius exception, right? So this is a new kind of error you would like to throw for your particular method, okay? So now, if you want to create this exception class manually, what you can do is you can simply say invalid radius exception, okay? You don't have to memorize this, okay? If I do want to test you on exceptions, I will give you the classes for the exceptions. You don't have to create them by yourself. There's no point. Just that when you do your assignments or for your projects, you have to know how to create them by yourself. In a test, you don't have to worry about creating the exception classes yourself, okay? I want to highlight a few things over here. First of all, you can see this is the name of the exception over here, and then we'll say extends exception. Don't worry about extends just for now. Extends is something to do with inheritance, which we will cover after reading week. Okay, not yet. It's too advanced for now. The way you can understand this, we say extend. We are simply telling the Java compiler or runtime that this new class I'm creating is a new kind of exception, just new kind. You can create as many kinds of exceptions as you like. Okay. And then over here, we simply define the constructor for the exception, right? And the constructor over here is simply taking some string value. And then super, I will rather skip it now. Don't worry about it. Again, you don't have to memorize it. Okay, we'll get to super again when we talk about inheritance. Now, something very quickly. How do you create exception class semi-automatically using Eclipse? I will show you. Let's go back to Package Explorer over here. Let me just delete this exception class I have. You can expect that as soon as I delete that, I'm going to have some compile time error. Not surprisingly, right? So now if I go to the circle class over here, you can see when I say set radius throws invalid radius exception, right? It must complain something like you're trying to throw this particular kind of exception, but the class does not exist, right? Eclipse is quite useful in this respect. If you move your mouse over the red line over here, I'll read it to you. It says that invalid radius exception cannot be resolved to be a type, which means it has not been created yet. And you can see sometimes Eclipse gives you very good suggestion about how to fix it. And the first fix is, why don't you create that exception? If you click on that, it will bring out the panel for you and then say, would you like to create an exception? Yes, I want to. If I say finished, it creates for you. That's why, but it's only semi-automatically. Because remember over there, in the circle class, when we say throw new exception, this particular constructor takes a string message. So that's why you have to define the constructor there. So that's why it says semi-automatically. Okay, again, don't memorize, but I'll just put it down for you. Okay? Okay, you can simply say the name of the class over here, and then I'll put string s super s, and everything will compile. Okay, any question about this? Again, for creating the exception classes, you don't memorize that, okay? Any question about this before I move on? Okay, very good. What I would like to go for now is I want to go back to our bank example, okay? I would like to do maybe two more examples. One is the bank, okay? The bank, we did the version without the exceptions, and now I want to introduce to you the version with exceptions. And then I want to do a brand new example, which is a little bit symbolic to show you how you can handle the exceptions, okay? These are the two, okay? Okay, so now that's about the exception here. You can read it through, exactly what I said. So now what I want to do is, let's go to the iPad here, okay? Again, we got three classes over here. We got account, we got bank, we have account, we have a bank, and we have bank application, right? We got three classes over here, okay? I'm going to show you how the exception handling has been done over here in a very similar way, very similar. Okay, let's go through this very quickly. Okay, for the account class, basically everything is the same. I'll just highlight the difference for you. So we have throws invalid transaction exception. And then we say if, this might be something related to what you just asked me before, okay? Have a look at this line over here. When we say if A less than 0 or balance minus A less than 0. Okay? Apparently, I combine two error conditions into one to say if you satisfy either one, it's going to be some invalid transaction exception. Now, let me just make things a little bit more informative. I want to know exactly which one I violated. What I can do instead is by creating two exception classes instead. Okay, I'll show you on the iPad. You can definitely try on Eclipse. Okay, things should be very straightforward, and then I'll show you what should be the change. So what I will do is I'll write it over here. So over here, just for this part over here, I'm going to rewrite slightly. So I'm going to say if A less than 0, I'm going to say throw new. So let me just call maybe negative amount exception. Negative amount. Okay, so NAE will be a new exception class, negative amount exception. Okay, just use acronym. Okay, that's one. And I can do else if. And I can say else if, the second one, balance minus A less than 0, so that's the second error condition. In this case, I can say throw new, let's say amount too large exception. So the convention is every time you have an exception class, end it with exception. Okay? And then I would say too large, for example. Okay, so over here I got amount too large exception. Okay, just to be complete for you. Oh, sorry, say it again. Low battery? Oh, thank you, thank you, thank you. That's a little bit surprising to me, but do I have the, yes, I do. Thank you. Oh, I gotta do it quick, There we go. Okay, nothing to worry. Okay, so amount too large exception here. Okay, so now, and then of course for the else part, it will be just like this. Okay, that one, no change. Now, question for you. Also, this can also test your understanding. If I do the blue and green version over there, which means I can throw two possible exceptions. What should be the first thing to change in the account class? Anything else to change? Throws, exactly, because now what the API says is not accurate. It says throws invalid transaction exception, but the green and blue mention nothing about that. Okay, so what I can do over here is, instead of that, I would say over here, okay, that means an alternative version. I would say throws negative amount exception separated by comma, okay? And then amount too large exception. So that'll be the first change, okay? Your exercise is to turn my handwriting here into Eclipse, Java code. That will be your exercise, okay? Okay, that's about the account class, okay? So now you can see that over here. Let's go to the next class, bank. For the bank class, apparently you can see that what we have to change is, again, for the bank class, because we are trying to make the method call over here. Let me show it to you. Okay, withdraw my throw either of the two exceptions. Again, we got two options over here, right? So now let's say we choose option number 2, which means we're going to throw invalid transaction exception. But for the other version, this is not accurate, right? What you got to say is something like this. You're going to say throws NAE, comma, ATLE, right? Just change accordingly, yes.
Do we need to make two classes, one class for each of the...
Correct, second question. So in this case, for NAE and ATLE, they correspond, each one of them corresponds to a new class for exception, like how I created for you, yes. If I do want you to use these exception clauses, multiple ones, I'll give them to you. So don't worry about creating them. It's just that when you do your project, when you do your assignments, you should know how to do that by yourself, right? There's no point to memorize this. Okay, finally, the interesting thing is here. Over here, when we try to do try and catch, let me just show you over here. So when you say B dot withdraw 23 and A, right? The withdrawal has the potential to version 1 to give you the invalid transaction exception, or the version 2 to give you either of the two exceptions. Now, let's say for version 2, how should we change this try and catch block here? Sure, go ahead. Yeah, you're going to add another catch, right? Yeah, exactly. Basically, the catch block, each catch block is going to correspond to a particular kind of error that can be thrown from the try block, okay? Because we know that from version number 2, we know that over here, either NAE or ATLE can be thrown. So that means what we should do is, rather than this particular catch block, let's replace it by, you can say catch. Catch, and then we'll say NAE. I'll say E over here. Of course, you can do something here. And then we have another catch block, and then ATLE. And over here, you can also say E. So these two E's are simply local to their corresponding catch block, so there's no conflict. Okay, that's another catch block. If you have more than one exception that can be thrown, that's how you do it, with multiple catch blocks. Okay? Any question about this? Are we doing okay so far? Okay, I'd like to do one more example. And this will hopefully reaffirm what I just said about the two options, either to try and catch or to propagate. Okay, okay, what I would like to do is, let me show you what I want to do here. Okay, so for the slides about the bank, it's already being explained on the iPad, so you can just go through the slide. They're self-contained. Okay, I will talk about exception in general in the beginning of next class, so let's not worry about this. Okay, this is just words to read. Okay, so now, what I would like to do is, for this particular example, I'm going to give you 3 possible scenarios where we have a call chain of 1, 2, and 3 methods. And then we want to see where can the exception be handled. Okay, it can be happening at different points. There is really no right or wrong. It's just about, for you as an implementer, where would you like to handle that? Okay. Let's just go over the big picture first, and then I will show you. Also, the code I'll make available to you. Okay, let's say, again, I make it very symbolic, okay? Let's say we have a class A, and then we have a method called MA, method for A. And then it takes an integer. If the integer is negative, there should be some kind of error. In this case, throw some exception, right? Otherwise, we do something useful. Okay, so that's the level, first method. Okay, so when you call MA, it might somehow throw some exception eventually. Okay, so now second level here, we have a class B. It has MB as the method, right? And then you can see that over here inside MB, we call MA. Right, very similar to how you call withdraw from the bank class. Okay, and then the third class is actually called a tester. In this case, I have simply just called MB over here, right? Again, MB, depending on how we decide to handle the exception from A, MB may have to be handled differently, okay? But we're going to show you 3 different versions. Okay, let's go through the big picture, and then I'll walk through with you the code one by one. Okay, first of all, let's just create a new exception class, either manually or semi-automatically in Eclipse. Okay, let's call that negative value exception. Okay, so now, this kind of exception may be thrown by calling a.ma, which means MA over here might throw this particular kind of exception. Okay, so now let's see the different versions. So version number 1, we want to handle that in class B, which means we want to handle the exception right here, which means we want to do try and catch over here, what we call MA. Version 2, we simply say MB throws that particular exception. We propagate. And then in the tester, we do the try and catch. Okay? Version number 3. In tester main method, we also propagate that exception to the console. So that's why in the main method, we don't have any try and catch. We simply say throws that particular exception. So we got 3 versions over here. Okay? So what I would like you to really see is to see for the different versions, what's going to be output. That's really important. Okay? Okay, and then we'll go for that. Question before I go on. Yeah. Go ahead.
Going to be passed any real.
Sorry.
Just handled in class A.
Oh, good. Wow. Typically, at the first point when you actually try to do something, that's where you throw the exception. So you don't really handle that over there. You just throws. Yeah. Okay, let's see the 3 versions over there. And then, again, the best way to show you maybe on the iPad. Okay, over here. Let's just go over all the versions here. And then maybe if we don't have time, I will show you the Eclipse maybe in the beginning next time. But at least you can go over the code. Okay, version number 1. First of all, for version number 1, we know that for MA, it throws negative value exception and also throw new negative value exception, right? That's for version 1. I believe for version number 2, it's the same. Just the same for this part. And for version number 3, it's also the same. So this part is just the same across the 3 versions, right? So somehow we have to know how we can handle this particular exception differently, right? Okay, let's see for version 1, how do we handle that? For version 1, so now let's say over here. Over here, we have the method called OA.MA. So we're calling this MA, which might throw negative value exception. So now let's say for class B, method MB, we choose not to propagate. We choose to handle that right away. So that means you can see that over here we got, over here, the try and catch right away. Okay? Notice what happened in the tester. Do we have any try and catch here? It doesn't need to, right? Let me write it down for you. Basically, you're saying the following. Negative value exception is handled here. There is no need. So there are 2 things I would like to point out for you. Number 1, you can see as part of the signature for MB, we don't have to say throws negative value exception, right? Okay? So there's no need to have the throws negative value exception for MB. And number 2, no try and catch in the tester.main method when calling MB, right? So these are the 2 things, which means we handle that exception right at this level and stop over here. It will only propagate further if we didn't have the try and catch block. Let's see, that's version 2. Okay, let's see that very quickly. Okay, let's go to, all right, see you on Wednesday, of course. Yes, let's see for version number 2, okay? So now you can see that over here, no try-catch block. Which means we choose not to handle this right away. We choose to propagate it. That means we got something like this. Throws negative value exception. Okay, so now we come to this level over here, tester. Now for the tester, we got 2 options. We can either choose to handle that, which is version number 2, or we can choose to propagate it, which is version number 3. For version number 2, we got try and catch, right? Because we are trying to call MB over here, and it might throw this exception, so we just try and catch. Okay, it's handled. Okay, so just mention to you over here. That's why you see that for the main method here, no need to write throws negative value exception. There's no need to do that. Okay, so now you can see that we have demonstrated at different levels. Now let's say for the last level tester, what's the other option? Oh, by the way, do only one option, but not both, either one. You cannot also not choose any option. You'll get compile time error. You got to choose exactly one. Now for the tester, we chose the option to handle that right away. The other option is we want to propagate it, right? That's version number 3. So you can see version number 3 over here. You can see basically the exception might be thrown from MA. It was not handled in class B. No try and catch. Also, it was not handled over here. No try and catch. Okay? And notice what we did. Over here, you can see we have to say throws, negative exception. This is the case where you have nowhere else, nowhere further to propagate the error. You will simply propagate to the console. Okay? Any question about this? Are we all right? Okay. Questions? Yes.
We can choose where error we can try to process the exception, but can we just create an exception inside the lowest level program, like class A?
What do you mean? I don't quite get you. What do you mean? You mean to create an exception inside the class, or what do you mean? No, actually, the exception must be a separate class. You don't really create as a nested class. That would be too complicated. Okay, good. All right, guys, you have no questions there. Okay, so far we have seen quite many examples already about exception, right? As I said, it's quite subtle and tricky. Go through them, and if you got questions, let me know. But I do want to just go for a few more things, and then we are done. Okay, we still got about 10 minutes or so, right? But we'll see. Okay, handle, we're not to handle over here. Okay, let me just go through very quickly so we can finish exception today. Okay, this is a little bit more formal answer. What's really exception? Basically, exception is just an event at the runtime. You want to say, at this point, I'm going to throw this particular exception because something has gone wrong. Whoever is using this method must do something about it, either to handle that using try and catch, or they can simply propagate the error. Okay, so that's something we have said. Okay, what I want to do is, you can read them through. I want you to look at one principle I would like you to know. Okay, this is the example I just went through for the 3 versions. You should go over them again. This one is a little bit trickier. I will go through them in the beginning next time. But I do want to talk about this principle over here. Okay, this is basically what I talked about so far. The catch or specify requirements, right? Remember I talked about option 1 and option 2. Option 1, you might do the try and catch. That's a cached part this year. Or you might propagate, in which case it's a specify requirement, which means you specify as part of the signature throws that particular kind of exception. Okay, the try and catch, the catch or specify requirements basically tells you whenever you're calling a method which might throw some exception, either catch or specify. All right. Okay, so you can either catch. So this is one case, right? Let's say you do c.set radius minus 10. You just do try and catch. That's a catch option. Or you can do specify option, in which case, if I try to do withdraw, which might throw the illegal transaction exception, in which case, I don't try to do any try and catch over here, which means I'm propagating the error to whoever my caller is, in which case I just say throws this particular exception. So catch or specify. Okay, let me show you a very useful case for exception. And for other things, I'll briefly mention because many of the slides, we have to go over them after we talk about inheritance. So I'll tell you exactly when to stop. Let me see if I got that example over here. Example. Okay, this is what I want to show you. You might find it useful for your own developments. This is part of the API. Remember we talked about integer class, which is a wrapper class, right? Integer class supports a method called parseInt. We will talk about, you can see the static method over there. We'll talk about static a little bit later, maybe in the week or next week. Basically, it's saying that when a method is static, you can simply call the method with the class name. So you can say, capital case, integer dot parse int. Okay? So now let me give you one example over here. Okay? So this will be a very nice usage for for the try and catch. So now let's say this. I can say integer. Okay, let me just double check. Okay? Okay. If I say integer dot parse int, it has to take a string. If I say 256 as a string literal, apparently this string can be converted into integer. So what it will do is it's going to return 256 as an integer. That's a normal case. On the other hand, if I say integer, dot parse int. Now over here, for example, I say 2. Apparently that cannot be converted into an integer. What that will do is it's going to throw a number format exception. Okay? So far so good? That's about how the parse int method will work. It's part of this Java Standard API for the integer class. So now I have a challenge for you. We'll talk about it right away. We do have time. Okay, what I want you to look at, this is the, okay, so because 23 and also 23, okay, so there are two different cases. So now I want you to consider, we want to write a fragment of code that is going to prompt the user to enter a string. The string can be either, let's say 23 is a string literal, or 20-3 spelled out. And then we want to somehow, if the user input is not a valid integer, you want to prompt them to enter again. Okay? It's a little bit similar to the circle calculator number 2. A little bit similar. Okay? So now, any idea how you can write it? Okay? Why don't you think just for 20 seconds? Okay? And then we'll go over solution and we're done. Okay? That's going to nicely conclude what we have learned today. And this is a very useful application. Basically, this is the logic. I want to keep prompting the user as soon as they actually enter something that wouldn't trigger a number format exception. That means we got the number we like. Otherwise, we're going to keep prompting them, right? That's kind of circle calculator 2. Okay, let's have a look at the code here, and then we are done. Okay, guys, a few minutes, okay? That's fine, no problem. Okay, let's take 2 minutes, and then we are done. Let's say we have a scanner object over here, okay? And then we have some Boolean valid integer, right? Very similar to what we did before, like a valid input. Initially false. And we say while the integer we are entering is not valid, while it is the case. So initially, not false would be true, right? Initially, so we go into the loop. And now over here, we say enter an integer, and we simply read the user input as a string, okay? And now, this is the critical part. We do try and catch. Let's think about it this way here. We say try, we simply say whatever the user input is as a string, parse int, call that. And then try to assign whatever the result is to user integer. Question for you. If I enter an input like this, if I enter input like this, 256, for this line here, it should be successfully parsed and then give me 256, right?
First they ask you again.
Huh?
It's going to ask you again to give a number.
No, if I give 256, that's valid. So you wouldn't ask me again. You shouldn't. Yeah. No, we'll see. On the other hand, if I give just a string literal 2 over here, in that case, we would expect some number format exception to be thrown from here, right? The flow should be interrupted. Okay, so here comes the trick. You can see exactly the same trick as before. If we can reach this line over here, from here to here, if we can reach this line, valid integer is assigned to true, what does that mean? That means a number format exception did not occur, which means the string the user passed is okay to be converted into integer. Otherwise, it should go to the catch block. And if we go to the catch block, in which case, we just maintain the Boolean variable to be false. Okay, and then eventually when we go back to the while loop, it's going to go accordingly, right? Either case. Okay, so that's a nice application. I'll take one more question and then we're done. Okay.
Then I will not waste the chance.
Do you need any question? Yeah.
Yeah, like afterwards, I will not waste the chance.
Okay. Okay, guys, any questions? Are we okay? Okay, so lab number 1, part 2 is released. Do spend some time on that. Okay, we'll see you on Wednesday.